Right. Afternoon. Let's continue with our differentiation. All right, we have two more little things to do in differentiation and we finish, right? One is called implicit differentiation, and the next is called partial, right? All right, ready? All right. So just to give you a quick idea on the two types of differentiation, I wanted to show you the difference between them. I just want to show you the difference between them, right? We have two types of differentiation to look at: implicit differentiation and partial differentiation. Right? So let's just say I gave you something complicated, right? Let's say I gave you xy squared plus y plus 2y, let's say, right, is equal to 5x. Right? Sometimes you will get equations where it's a little bit difficult to make x the subject of the formula or y the subject of the formula. So sorry. So in cases like that, what we'll do is we will try to differentiate y. So we know this already. We know that if we differentiate y with respect to x, we're going to get dy dx. But suppose you had y squared now. How you will differentiate? What's the differential of y squared? So to differentiate y squared with respect to x, you're treating y as a function. So you're treating y like this, 2x minus 1 squared. So you'll bring down the power, differentiate inside the bracket, put back the bracket, and minus 1 from the power. Remember that? So what will be the differential of y squared now? The differential of y squared will be bring down the power, you differentiate the bracket, which is y in this case, you'll get dy dx and minus 1 from the power. So you'll be left with 2y dy dx. So you'll be left with 2y dy dx. So in short, in order for you to differentiate something like this, you're treating y as a function and you're differentiating the xy squared, product rule, 2y, and then you're differentiating this. After you do that, you make dy dx the subject of the formula. Right? So you're going to differentiate y, and y is basically a function in x. Okay? But on the other hand, partial differentiation, if I gave you something like this, let's say I gave you an equation in terms of x and y. Let's say the equation is 2xy plus y squared plus 3x. To partially differentiate, what that means is that we're only considering part of the function. So if I ask you to partially differentiate, you will see the d looking like that. It's not going to be a straight d. I'll have a little curve in it. And here what you could do. You could partially differentiate f with respect to x. So what that means is that everywhere you see y, in this case, you treat y as a constant. So technically, let's take off y, right? And we differentiating 2kx, right? Remember, k is like y squared plus 3x. So to differentiate partially, we're treating y as a constant. So the differential of 2yx will just simply be 2y. What's the differential of 2x? And 2, right? 2 is a constant, right? So if I put a next constant next to the y, the differential of 2y is simply 2yx is simply 2y. Okay? And the differential of y squared is a constant, so that'll be 0. And differential of 3x is 3. Okay? So basically, what I'm trying to hit home here is that when you're differentiating implicitly, y is a function in terms of x. When you're differentiating partially, x or y will be a constant. They are never both variables. One is a constant, one is a variable. Okay? So that's the difference between both of them. All right, online, that make a little bit of sense. Aiden, Celine, are you okay with that? So implicit, y is a function, partial, x or y will be constants. One's a variable, one's a constant. Okay? We are going to focus on implicit differentiation. Right, so we're going to focus on implicit differentiation first and then partial. Ready? Implicit differentiation, right? So for functions, change my ways order. I started right good. And I start to write. Preparing the live stream and now working. Right, so for functions, that cannot be written in the form y is equal to f of x, right? We use implicit differentiation to obtain dy dx, right? Right, we treat y as a function in terms of x and right, and the differential of y to any power, the differential of y to any power right, and the differential of y to any power is n y to the n minus 1 dy dx. Right, quick example. Quick example, if I ask for the differential of y cubed, it will be 3y squared dy dx. Right, as I was showing you earlier, right? All right, so how we doing this now? Anybody writing there?
Yeah.
Yeah, okay, go ahead. Hey, William is here, mate. Okay, messaging about you. Bum, 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 bum. Pack already. Tomorrow they'll finish pack. How much are they going from Trinidad? 30. Oh, that's not plenty. Or there's a fundraiser or something, right? Or
Yeah.
or you'll do fundraiser or something. All right, let's see. Let's try an example, a full example, right? Right. So if you look here, it is okay. There's a bad example. Like put a squared here. Let's say I give you something like this: 3x cubed plus 2y squared plus 3xy equals to 10, right? If you look at this, it's a little bit difficult to make y the subject of the formula. So in a case like this, you're going to have to differentiate implicitly. So we're going to differentiate each one piece by piece, right? So if you differentiate x cubed, you'll get 3x squared. That's straightforward, right? If we differentiate 2y squared, you will get 2y dy dx, right? That's the formula I just gave you, right? 2y all squared, bring down the power. Sorry, that should be 4. Bring down the power, write back the 2, differentiate y, and then write back y minus 1, right? So again, 4y dy dx. Okay? Nice. And then the last part, we have a little problem here. In order for us to differentiate this properly, this has to be treated as a product. This is a u and this is a v. Right? So you're going to have to say that u is 3x and v is y. So du dx is 3, dv dx is dy dx. So we're going to use chain rule here. U by dv dx, 3x dy dx plus v by du, that's 3y, is equal to 0. Right? The differential of 10 is 0. Okay, differential of 10 is 0. Now we're trying to make dy dx subject to the formula. So we'll leave all the dy dx on the left. So that'll be 4y dy dx plus 3y dy dx is equal to minus 3y minus 3x squared. And then factor out dy dx. 4y plus 3x. Right? Factor out dy dx and then make dy dx subject to the formula. And you'll get minus 3y minus 3x squared all over 4y plus 3x. That's it. So you differentiate each one individually, and then you separate dy dx and you factor it out. That's okay? Supposed to be simple, except you have to remember that 3xy is a product. Okay? So I just want to go over that right here in blue, right? 3xy is like a product. Y is a function in x and 3x is a function in x. So u is 3x and v is y. So when you differentiate 3x, you'll get 3. When you differentiate y, you'll get dy dx. And then you work out with product rule, multiply 3x by dy dx and 3 by y. That's okay? That's basically what we did.
So my internet froze for a bit there.
What's that? And then
Thank you.
hang it.
So the internet by me froze when you explained the part in blue.
Oh, no, all I was doing is just do product rule on the right side. So I use product rule and I'll show you the right in there. See that? So I choose 3x
Yes,
as u and y as v and so on. See that?
yeah, sir.
Okay. Finish? You know. I say let's do it part by part. Just look out for the product rule, right? That's generally where some people make mistakes. Right, just try when it to get warm with. Finish. I try this here. Try that, please. 3x squared y squared plus 4y is equal to 6x. Right, someone to finish. Let's see how it looked. This is your U and this is your V, right? Hey, Krishna. Hey, by the way. Oh, she, okay. No problem. Yeah. So this one line next side. Oh, I thought this saw a line on the next side of the building. No, but that's probably. Okay, okay. Okay, so okay, okay, all right. All right, well, let me come down here. Yeah, y'all got that? Check it and see the differential of 3x squared y squared. Oh no, it's y squared. Oh no. Scrap that. Right? I made a mistake there. So that's 3x squared. The differential of y squared will be 2y dy dx. Right? Plus 6xy squared plus 4 dy dx is equal to 6. Sorry there. So that'll be 6x squared. That'll be 6x squared y dy dx plus 4 dy dx is equal to 6 minus 6xy squared. And then you could factor out dy dx. And you will get 6 minus 6y squared over. Yeah? That's it there? I made a mistake the first time. Sorry. Anybody got our online? Koi? Are you okay there? Rana, you all okay there? Chain rule part confusing. Okay. I'm gonna just do it over, right? I do know about the chain rule part. So this is your U. So U is 3x squared, and this part here is your V. V is y squared. So the differential of U is 6x, and the differential of V is 2y dy dx, right? Remember the technique? Bring down the power, differentiate the bracket, and minus 1 from power. So you'll be left with 2y dy dx. And then you just plug it in the formula. 3x squared by 2y dy dx. Remember, it's this by this, and then this by this. And you will get plus 6xy squared. Yeah. Nice. Let's try next one. Changing it, right? Since you all don't like the chain rule, sorry, the product rule, I'm gonna give you one with plenty product rule here. 6x² y plus 2x² y² is equal to 4xy. So I'll give you 3 sets of product rule here. Go ahead, have fun. Have fun here. We're now having fun, as I said, so go do it, right? Put up your book. Go out and answer. Check out what the deal is. You look. Where it's plenty of that's really the idea together. So one side, everything else on the next side. I just tried to, I didn't want money, but I'll talk there. Bam, bam, bam. Shivani, I see yours right here. I saw the pic. I got started in about 1 minute. I just waiting on William to send a picture. William almost done. Bam, bam, bam. William and where's Shivara? Shivara is not there. Da 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 da. Huh? Andy? I think I see Andy name. Andy not there. Oh, it's Andy I was waiting on. It was somebody else who said it. Right, let's check it out. So it's 3 sets of product rule, right? So we're starting with 6xy squared. That'll be, sorry, you see, I write it wrong already. It's 6x squared y. So that'll be 12xy plus 6x squared dy dx. That's the first part, right? Then we have 2x squared y squared. So that'll be, I put it in the wrong order, but it don't matter, right? It don't matter, commutative. So that's 2x squared y squared. Right, when you differentiate that, you'll get 2x squared by 2y dy dx. plus 4xy squared. Okay, so there's the first part. Second part, third product rule is 4xy. So that's 4x dy dx plus 4y. That's okay? Check and see if we have the three parts, right? So now we're going to put it together. So that'll be 12xy plus 6x squared dy dx plus 4x squared y dy dx plus 4xy squared is equal to 4x dy dx plus 4y. Of course, we do the usual thing, bring it dy dx on the left, everything else on the right. 6x squared dy dx plus 4x squared y dy dx minus 4x dy dx is equal to 4y minus 12xy minus 4xy squared. So we're left with dy dx 6x squared plus 4x squared y minus 4x is 4y minus 12xy minus 4xy squared. So dy dx is 4y minus 12xy minus 4xy squared all over 6x squared that's okay? Yeah? Nabil? So you just have to be careful with the product, right? Do them separately. Do it. Oh yes, by factorize, but check it out. If you're not seeing it, I'll check it for you, right? Any questions online there? Finish here. Okay, nice. Right, so good. So since all again the hang up it, I'm gonna put E and learn on thing now, right? Bam, 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 bam. I'm just giving you a whole set of different things, right? And then we do partial analyze it. Should have a slight head start when school begins. We just focus on integration, right? Yeah, I put a little on now and a little E. I'll put E first. The one in lawn is a past paper. Open up my pencil will die in way. What's going on? Pencil. Copy this one down. Anybody having anybody having issues? Ba, 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 ba. Yeah, I can take it off. Take an E first, and then I'll give you a lunch. Finish? I'll give you something easy, right? This is number 4. Try that there. Same rules, everything apply. And I'll give you a launch. Take your time and do it. It's up to you. You could break it up as a product like e to the x by e to the y, or just differentiate it just like that. You have your options, right? Why is this? Finish. Okay, listen. All right, let's see how this one went. Right, so we have a few options, as I said. You can work it out as it is, or you could write 4EX by EY and do a product if you want. Okay, you can do it like that. Or you can differentiate just like that. You'll get 4 by differentiate x plus y, you'll get 1 plus dy dx. Then write back EX plus y. Same way we differentiate eta f of x, right? Differentiate f of x and put it in front. Okay? Minus 4x equal to 4. And that's it. Right? Let's multiply it back out. So, huh? Tell me. Howdy? Howdy 4. Oh, on the end here, sorry. Sorry there. So that'll be 4e to the x plus y plus 4e to the x plus y dot dy dx is equal to 4x. So that's 4e to the x plus y dot dy dx is 4x minus 4e to the x plus y. So you will get dy dx is equal to 4x minus 4e to the x plus y over 4e to the x plus y. And if you look closely, you could also write it like this. xe to the x plus y minus 1. Either one could work. Right? But if you have up until the second to last line, that's good. Yeah, do it over again, yeah, no problem. So you differentiate the power. The power is x plus y. Right? The power is x plus y. And then take the power and the differential, the power, put it in front, of course. And then write back e to the x plus y. The differential of 2x squared is 4x. And the differential of 4 is 0. I multiplied back out. So I got 4e to the x plus y. And I got 4e to the x plus y dy dx is equal to 4x. Right? Dy dx here, I carry across this. And then I carry this across. That's it, you're good to go. Better, William? Anybody? Are you okay with that? All right, fix it. Are you okay with that? Let's try one more. We finish with this, right? Let's try a ln. So remember, just go over quickly how to differentiate ln. Remember, to differentiate ln, to differentiate ln f of x. F of x is your denominator and your numerator is the differential. Okay? Let's remember that, right? So I'm going to give you a ln. This is a past paper. This came in quite in 2013. Right, find dy dx here. Ln x squared y. Again, if you want to use it, you could break it up, right? Minus sine y, bring in a little sign now, is equal to 3x minus 2y. Equal to 3x minus 2y. Try that there. Right, in case you get in trouble, you could remember you could do this, huh? And you can break it up like that. Or you can leave it like that and you product rule on top. It's up to you. Anything you want. All right, let's see how it looks. The differential of ln x squared, you have 2x on top. The differential of ln y will be dy dx on top. What's the differential of sine y? So try to remember how to differentiate sine 2x. It will be 2 cos 2x. So the differential of sine y will be the same thing. Differentiate the y, you'll get dy dx. Differentiate sine, you'll get cos, and then write back y. Just in case you didn't get that, I'll give you a little minute to fix it there. Fix it quick. I'll fix it. Fix it. So here will be 3. Here will be 3 minus 2 dy dx. What do we do with that y underneath there? We'll do the y underneath. So here's what we have, right? We have 2 over x plus dy dx over y minus dy dx cos y is equal to, well, I'm bringing across that 2 dy dx one time. What we could do with the y? We could multiply it out, right? We could bring it on top by well. We could get rid of it by multiplying out by y, right? So we'll get 2y on x, right? I'm carrying across that 2y on x one time. So we'll get dy dx on y, sorry. We'll get dy dx minus y dy dx cos y plus 2y dy dx is equal to 3y minus 2y on x. So I'll multiply everything out by y, and then I'll make dy dx subject to the formula. Dy dx will be equal to 3y minus 2y on x. Actually, if you wanted, you could multiply everything by xy. Okay, to get rid of all the fractions. But you will still get a fraction in the end. So you'll end up with 1 minus y cos y plus 2y. Anybody get close to that? It's based on how you handle the y. Right? If you had 1 on y here, nothing wrong with that. Instead of just 1. Anybody got it like that? Okay. But you leave the 1 on y. Okay, yeah, nothing wrong with that. If you left the 1 on y, it may have looked like this, right? 3 minus 2 on x all over 1 on y minus cos y plus 2. It may have looked something like that. Anybody get one of these? Or if you did it the other way, oh, okay. Or you meant instead of ln x squared plus ln y, you have something like this product rule. So you have 2xy plus x squared dy dx. Yeah, that could work. That could work. But you just have to take your time and simplify it, right? It should in the end give you something similar. All right. No, it wouldn't look exactly like mine. Let me show you. But I show you because the last one I'm doing, right? So you will get x squared y underneath. You'll get 2x, right? You will get 2xy here plus x squared dy dx. Right? Minus dy dx cos y is equal to 3 minus 2 dy dx. If you want, you can multiply everything by x squared y. So you'll get 2xy plus x squared dy dx minus x squared y cos y by dy dx minus 2x. I bring across the 2 dy dx, right? So that'll be plus 2x squared y dy dx is equal to 3x squared y. Right? And if you factor out dy dx, the right hand side will be 3x squared y minus 2x all over x squared minus x squared y plus 2x squared y. Wait, I'm looking way better than some looking. I leave out something. Cos y. Yeah. All right, good. You're looking way better than the next one. Right? That's it. Okay, so this much better. So take this one instead, right? Nice. So that is your implicit. All right? Take a little 5 minutes and then we do some partial. I was going to finish it today, you know. But I want to tell the parents come for early, but it will still come here 5 o'clock. I know your parents is come here late. Your brother, what time you come here? Tell them finishing early, right? Tell them half 4. Tell them half 4. I saw half 1. I was going to finish it. Tell them like half 4. Right? Take a little 5-minute break and then we start partial. You know, we had the time and the all right. All right, let's go back. Partial differentiation, right? Right, so I'm not sure we've seen all this here. So partial derivative, if we have a function f of xy, right, and we could find the derivative of f of xy with respect to one variable, right? And the way we'll do that is by holding the others as constants. Oh, crap. By holding the others as constants. So for example, if I give you f of xy, then the partial derivative, you'll notice that you have little curly d's here. Right, just have a little curve on it, a little extra curve, right? Once you see that, that's the partial derivative. So if you see the partial derivative of f with respect to x, it means that you're differentiating with respect to x by holding y constant. Right, you can screenshot that first. Yeah, and also it could also be the partial derivative here. So this is where you differentiate with respect to y and hold x as a constant. Right, so it's important that you could do that, right? And then you have to be able to do second derivative. Right. Let's say I give you something like this now. And I want you to get the partial derivative of f with respect to x, and then we'll do it with respect to y. Right. Before I do anything, here's what I like to do, right? So that we know y is a constant. What I like to do is this. You see, if I have 2x squared, y squared, I like to write it like this: 2y squared, x squared. So in my mind, I know that this is a constant. And of course, well, 3y is a constant, right? So I know with respect to x, this one is with respect to x, right? With respect to x, I know I'm differentiating x squared, that'll give me 2x. If I differentiate 2y squared, x squared, that'll give me 2 by 2y squared x. And the differential of 3y, which is a constant, that'll be 0. So the partial derivative of f with respect to x is simply 2x plus 4y squared x. If I were to do it with respect to y, right, with respect to y, then I'll just do it the other way around. Right, I'll leave my x squared here. I'll leave it as 2x squared y squared. So I know that this is a constant plus 3y. The differential of x squared, that'll be 0. Because remember, with respect to y, right? The differential of 2x squared y squared, bring down the 2. Right back the 2x squared as a constant, and a minus 1 from the power. And the differential of 3y is 3. So you're going to get 4x squared y plus 3. That's okay? So you're treating y as a variable, right? Y is not a function in x. So you will not get dy dx. Some people tend to mix up when they differentiate in y. partially derive dy dx, right? But it does implicit differentiation. It just treating y like a normal variable. Okay, so that's an implicit example there. I mean a partial differential example. Yeah, let's try one now.
Oh, it's still copying it down.
Was I just copying it down?
Yeah, just the last part.
All right, sorry.
Okay, I got you.
Get you? All right. I'll learn one time. Let's deal with the learn and done. Yeah, take it one time. All right, all right, all right. I wouldn't give you a learn. Just make sure you catch it and I'll give you a learn. Whoop, pop, 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 pop. Go ahead. Find both of them. Find the partial derivative of x with respect to x, partial derivative with respect to y. Quick, time you finish, and then I will give you a slightly trickier. All right, so with respect to x, we will get 6, right? Again, it will be 3. It will be 3y/x. It's simple for my just make the variable. All right, so that's the way you handle partial. Copy down. Okay, I'm just doing a few more of this on second order, right? I'm doing second order and that's it. Okay, let's look back at this. It's about 20 minutes again. You can look back at that part of the video. All right, let's try one a little bit different. Try this one here. Find the partial derivative with respect to x first. Take your time. I'm giving you 2 minutes, then I will help you. So you have to identify if it's a product or not. I'll get it out. Now, so we're treating 3y and we're treating y as a constant here. So these are constants. So pretend this is a key and pretend this is a key. All right, so let's say y is k actually. Let's do it in such a way that we could see it a little bit better. So before we start to work it out, let's see here's what y is equal to k. So I don't want the y to confuse you. So I'm going to get this new equation now. 2x squared plus 3k sine kx squared. Right? Hopefully you should be able to differentiate that, right? Could you differentiate that? Yeah. This will be a u. So u is equal to 2x squared plus 3k, and this will be a v. The reason why it's a product is because it's two equations in terms of x. And right, then you differentiate this. This will give you 4x plus 0. What's the differential of sine kx squared? What will that be? 2kx. So differential kx squared. So the differential of kx squared will be 2kx. Differential of sine is cos. Then you write back kx squared. So now you can see the partial derivative with respect to x is 2x squared plus 3k by 2kx cos kx squared plus 4x sine kx squared. Of course, k is y, so we could just put it back, right? Right, k is y, right? So just put it back. So that's 2x squared plus 3y, 2yx cos yx squared, 4x sine yx squared. Right? I just putting it back so that we don't mix it up, right? So by putting y is equal to k, it might look a little easier. Not really. Jude, it look a little easier. No, it's just a look at. But were you able to identify the product? Anybody confused? If you're confused, fine. Try the partial derivative with respect to y now. Try it with respect to y. Anybody confused there, Raul, Koi, Gabriel? You all okay? Try it with respect to y, please. Same function, right? Do it with respect to y. So I want to get the partial derivative with respect to y. So I'm going to let x equal to k. So I'll get f of xy is equal to 2k squared plus 3y sine k squared y. Right? Again, I should identify as a product because I have y in both functions there. So u is equal to 2k squared plus 3y, and v is equal to sine k squared y. So du here is 4k plus, sorry, constant, right? The differential of this with respect to y is 3. And the differential here is 2k cos k squared y. Right? Differential of sine and cos, right? And now we just gonna use the formula partial derivative. That'll be u by dv plus v by du. Right? Put back the x, right? So that'll be 2x squared plus 3y by 2k, sorry, by 2x cos x squared y plus 3 sine x squared y. That should just be k squared. Thanks. Shivani again, should I? Okay, so that's the way you handle it, right? One is a constant, one is a variable. I'm gonna just give you the rules for second order, and then we'll do a past paper. Right? So second order partial is the same thing. You're just doing it twice. Right? But there are a few I wanted to identify. If you see fxx, it means what it means is that you're doing it with respect to x twice. So I'm just giving it different ways that it could write it. So you're finding the partial derivative with respect to x twice. So you can see f subscript xx, or you could see partial squared f partial x squared. You'd have different ways you could write it. If we have fyy, same principle. F of yy partial derivative squared f with respect to y squared, or the partial derivative of y. Right? Either one of the ways could work. Right, so if you see fxy, It means that you're differentiating partially with respect to x first. And then with respect to y. Right? So it's the partial derivative with respect to x, then y. Okay, so if you see it looking like this, is this one first, then the y, right? X, then the y. And vice versa for yx. You're doing the y first, then the x. So that's why to be able to read it properly. So if you see xy, fxy, you do the x, then the y. If you see fyx, you do the y, then the x. If you see it looking like this, remember, you're doing the y, then the x. Right? Just try past people, and that's it. Remember, you can see more than one variable. You can see x, y, you can see x, y, z. Yeah. Last one, that's it. Let's see if we could do this here. So I'll give you a function in terms of x and y. See if we can prove that. Oh, you didn't come one time there, but X plus respect to X. Then respect to Y, and then respect to Z. I can respect to X, then respect to Y, and then double. It's a PMI. It's a true from in left equal to right. All right, let's see. Anybody got it? So let's see. Partial derivative with respect to x. That'll be 8x. 3y squared plus 7. If you do it again, you'll get 8. You just get 8. All right? If you do this second partial with respect to x. With respect to y now, you'll get 0, 6xy plus 0 plus 3. If you do it with respect to y again, you will end up with just 6x alone. So we have this, and we have this, and we have this, right? We need, which one we doing first here? If you see this, it means that you're doing with respect to x first and then y. Okay? You're doing with respect to x, then y. That's okay? I remember that, right? X, then y. So let us see how it looks. Partial derivative of f y x. So you're doing the y first, so I'm following, sorry, the x first. So I differentiated this with respect to y, and I will get 0 plus 6y plus 0. And now I'm going to plug it in the formula. Right? I'm going to plug it in the formula on the right-hand side first, right? So I'm going to get the second derivative with respect to y, which is 6x, with respect to xy, which is 6xy plus 3, plus with respect to x squared. That's it. Huh? Oh, what you wrong thing, man. Sorry. Right here, just 6y. Thanks. So we ended up with 36 xy plus 8. That's the right hand side. Left hand side now, it'll be 6 by, with respect to y, 6xy plus 3 minus 10. So that'll be 36xy plus 18 minus 10, which will give you 36xy plus 8, which is the right hand side. That's it. All right. A little bit long, right? But you have to make sure you do it in the right